All right, let's take a look here. So when we're looking at right triangles, you can see that there's going to be this nice relationship between the angle that's right here and some of these three sides. Now let's take a look. If I were to just move this off to the side here, and the uh, beta, the angle is 30 degrees, it stays 30 degrees. Notice they all three change. We know they're all three going to change because if it's a right triangle, you know that if I'm changing two of the sides, the third side changes. The Pythagorean theorem, right? So, well, look at what's not changing. As I'm sliding this back and forth, 30 degrees is not changing. And if you look over here, the opposite over the hypotenuse, this ratio, if I take the side that's opposite, the blue side here, it's opposite that 30 degrees, and the hypotenuse, which is always the hypotenuse, the longest side, 6.01 in this instance, if I divide those two, I'm always going to get zero point 0.5. Even if I change the numbers around, that divided by that is still going to get me zero point 0.5. So it doesn't really matter how big the triangle is or how small the triangle is. Now they discovered this way back in the Greek times, and they made all these tables. They created all these tables that said, listen, if you have a 30-degree angle, then the ratio of this side to that side is always going to be 1 to 2 or 1 over 2 or zero point 0.5. So rather than actually having to measure everything out, they just know that this side always has to be twice as long as this side, so long as that angle is 30 degrees. Even if I move it way out here, this side, the hypotenuse, is always twice as long as that right there, so long as it's 30 degrees. Now I can change that 30 degrees to something else, let's say 60 or something. Ooh, let's do there. There you go. And the ratio changed, right? I'm getting 0.87. But notice something. Even if I keep changing this, as long as 60 stays the same, now the ratio stays the same. 0.87. No matter how big or small the triangle is, that opposite over hypotenuse is always the exact same ratio. So they sat down and said, hey, if you have 60 degrees at this corner here, you know that this length, this blue length here, is about 87% as big as that one right there. And they did this for every single angle. They did it for angle of 57, angle of 54, angle of 53. That way, once they figured all this stuff out, they could just look at the table and say, hey, just tell me what the measure of the angle is. Let's say the angle was 45. The angle is 45, then they could look over and see exactly what the relationship is between those two sides. But it wasn't just those two. Take a look. Sometimes they said, well, what if I don't care about the opposite side? What if I want this adjacent side? Adjacent means right next to, right? So what if I know that this side here is 4.22 and I say I want to know the hypotenuse or something? Well, I know that the hypotenuse is, or excuse me, the bottom here is always going to be about 71% of whatever the hypotenuse is. That's basically what this ratio over here is saying. Okay. And again, it doesn't really matter. If you know the base here, right? If you know the base is 6.29 and you know you've got a 45-degree angle, they looked up at the table and said, hey, it should be about 71% of whatever the hypotenuse is. And they were able to calculate the hypotenuse. Same thing down here. What if they didn't care about the hypotenuse? What if all they had, now think about this like a building. You want to know how tall a building is, but you can you can walk away from the building and you can look up at the top of the building at a certain angle, right? Let's change that angle to back to 30 again, right there. And you walk away from the building, you look up at the top of the building and you measure that angle of 30 degrees. This is things that we can do as human beings. We can stand at the ground level and measure our angle of looking up. But if I could figure out that relationship between the opposite side and the adjacent side, that ratio should be about 58%, I can figure out how tall the building is. It's that easy. So we've got every possibility here. We've got opposite over adjacent, right? We've got adjacent over hypotenuse, and we've got opposite over hypotenuse. Every possible combination you're looking at is right here. And notice that if I keep moving these, they all stay exactly the same, right? Those relationships don't change. The only time they change is when I move the angle. As soon as I change the angle, say to 45, right there, then those ratios over here won't change at all, no matter how big or small the triangle is. Pretty cool, I hope. All right, bye.